Hello, my name is Lee McHugh. I'm an associate professor in the Department of Mechanical Engineering, and I'm going to talk to you a little bit about what we have done in the Vessel Dynamics Laboratory. So past and current research areas in the Vessel Dynamics Lab have focused on a handful of different areas, including computational and experimental fluids, dynamics, and occupational safety. And so within those umbrellas, the computational and experimental fluids piece, we have looked quite a bit at particle-based computational fluid dynamics and fluid structure interaction in particular. With respect to dynamical systems, we've done quite a bit focusing on simulating chaotic phenomena, as well as verification and validation of codes that are simulating chaotic phenomena. And this is largely because this path we went down was started by trying to simulate problems like capsizing, where we have this critical sensitivity to initial conditions that's often characteristic of a chaotic problem. Also done quite a bit looking at motion prediction for launch and recovery operations under the theory that if we can predict large motions, we can also try to predict small motions that would be optimal times to land, say, a helicopter on the deck of a ship. And these days we're doing a fair amount of work related to autonomous maritime systems. On the occupational safety side of things, I've been able to transition some of the work that I've done related to predicting capsize into tools that commercial fishermen can use. So we've taken an app-based approach, created the Small Craft Motion Program, which is a iPhone app for fishermen who might want to try to be monitoring the motions of their ship. Have FV Drills, which is a tool to help guide fishermen as they do their monthly drills for things like man overboard and abandoned ship drills. And I'm currently involved in a project looking at trying to quantify sleep deprivation or assess sleep deprivation amongst commercial fishermen. This has actually led me into some COVID-19 related work as well. We can use a lot of these modeling and simulation skills to be trying to transition to modeling what happens with viral spread in aircraft or amongst farm worker populations. And then to summarize some of this, I have a short video that I'll talk you through. So this is an introduction, is the Vessel Dynamics Lab. It's down at Mason's Potomac Science Center, have 3D printers, computational tools, and so on. This is an example of some of the fluid structure interaction simulation we've been doing. So this is a particle-based CFD simulation with a flexible membrane in the middle. This is an experimental effort where we're trying to generate a validation data set for somebody who might be looking at more extreme kinds of hydrodynamic phenomena. So this is actually an underwater deflagration. This is two different fuel-air mixtures on the left versus the right. And we can see that you have that rapid expansion and contraction as you would expect from the deflagration, even seeing some cavitation in there. And this is the same sort of experimental setup, only against a flexible membrane instead of against a flat plate. With the work that we've been doing moving to autonomous systems, we have a couple RC boats that an undergraduate researcher has been working on transitioning to autonomous operation. And so those are the couple boats, and here is one of those boats running in the pond behind Mason's Potomac Science Center. So this is tracking to the waypoints that the student has programmed and doing exactly what it is supposed to do on its own before being called back to the student standing there on the other side. And then this is some of that fishing vessel safety related work. These are the two apps that I mentioned before, Scramp and FV Drills. The Small Craft Motion Program, as I mentioned, was designed to help fishermen assess the safety of their operations. So there are a handful of different indices that they can see, a metacentric measurement, they can measure the roll period, identify parametric roll. And this is the other app, FV Drills, which can give a fisherman a random drill if they want some prompted randomness as they try to walk through their drills. So this was prompting an abandoned ship drill. They can check off when the drill is complete and then take them back to a log of the drills that they have done so that they have a nice recorded log of their operations. So that is my quick summary of what goes on in the Vessel Dynamics Lab. This does showcase some work done by past and current students John Gilbert, Van Jones, and Dewal Benderi. For more information and links to publications, please visit the lab website, which is vesseldynamics.com.